Hello students, this is Dr. Diaz and let's practice a little bit of significant digits. So remember, we have several rules to find the number of significant digits over here. Remember number 1. So rule number 1 is all non-zeros are significant. Okay? All non-zeros are significant digits. Good. So, and all zeros between non-zeros, zero between non-zeros are also significant. Okay. So, rule number 2: if a decimal point is present, zeros to the right of the last non-zero digits are significant. So if you have 5.00 grams, so I have 3 significant figures. The zeros of the decimal indicate that it was measured that precisely. As a result, we would say that this measurement was made to 3 significant figures. Okay, and other rule is rule number 3, which is 0 to the left of the non-zeros are never significant. Like if you have 0.0045 meters, these are placeholders for the decimals. They are not significant over here. Okay, so there are no significant digits. Good. So that is the most important over here to practice a little bit more with you. So let's practice then, and we can remember all the rules over here. Look at this first example here. What do you see? This number, how many significant figures or significant digits we have over here? So let's count. So we have a decimal over here, and this is after non-zero number, so that will be counted. So I have 1, 2, 3, 4, 5, 6 significant figures. And let's go over here. This number, we don't have decimals over here, so those numbers over here, they are not significant at all. Okay, so I have only 2 significant figures over here. What about this one? We have a decimal and I have zeros of the decimals between non-zeros, so it's easy. So I have 1, 2, 3, 4 significant figures. Okay, let's go to the next one. How many significant figures I have over here? So I have 1, 2, 3, 4, 5, 6. 6 significant figures. What about this one? How many significant figures we have over here? Can I count this? Yes, of course, because it's after the decimal and after non-zero number. So I have 1, 2, 3, 4, 5. 5 significant figures. What about this? Do I count this one over here? No, this is only the placeholder for the decimals. So I have 1, 2, 3 significant figures. Okay, so if I say 5 coins, how many significant figures I have over here? We don't count. Remember, when you have exactly numbers like coins, persons, we have exact numbers. Okay, so they are exact numbers. These are values for which there is no uncertainty. So, or it's 5 or it's 5. We cannot have 5.1 coins. Okay, there are 2 types of exact number. That is the counted values, like over here. So if you have 7 coins, we don't have uncertainties. Okay, so we don't count significant figures over here because they are exact numbers. Good. So if you see this in exam, 5 coins, 5 houses, 10 houses, you don't count the significant figures. Okay, so how is that in math? Let's go to multiplications. So when you have a multiplication and division, we gonna report the same number of digits as are in the least precise start measurement. That means the smallest number of significant figures. Like here, a vehicle travels 315.3 miles in the span of 5.2 hours. What is the average speed in miles per hour? So first thing, you're gonna use your calculator and you're gonna do, can I bring my calculator over here? Nope. So let's put it over here. So the first thing that you're gonna do is grab the number. If you have a calculator in your hand, you should, and you gonna multiply, you're gonna divide, right? Because they want miles per hour, so we're gonna divide by 5.2 hours, right? So here I have 1, 2, 3, 4 significant figures. So I have 4 significant figures. And over here, I have only 2 significant figures over here. So this has 2 significant figures. So my answer must have 2 significant figures. Remember, the smallest number of significant figures because they are the least precise. So here, if you bring a calculator, you're gonna have a number like this: 6.63461538. This is the number I got in my calculator. So, but my final answer must have 2 significant figures, which means only those 2 over here. But you need to take care of the rounding process over here. So if this number over here after decimal is greater than 5 or equal 5, then we increase the previous value in 1. So that means 0 goes up to 1. So all this number over here are going to disappear. So my final answer will be this: miles per hour. Okay, so when you have division, this is what you're gonna do. So what about when you have addition and subtraction? So let's go to this. Let me bring one example from the book of Macmillan. So it's a different book from our. Let me just put over here. Okay, let's use this example over here. So this, all the time that you have to add or subtract something, you're going to round to the last decimal place of the least precise start measurement. Let's translate this. So that means you're going to look to the number of decimals. And you're going to choose the smallest number of decimals because they are the least precise. Okay, so while you're training for Triton, you swim 0.432 miles, then bike 18.1 miles. What was your total distance travel? So you're gonna do is to add them together, right? So I have 0.432 miles, and we have 18.1 miles a bike. So when you add all together, I have 3, 2, 4 plus 1, 5. Here it's 8, so 18.532. But look at this. The smallest number over here is 1 decimal. So we need to stop in the 1 decimal because this is the smallest number, right? smallest number of decimals. So our final result must have only one. Since this second number is smaller than 5, we're gonna keep the same. So our final answer will be 18.5 miles. Okay, that's it. That's all. Bye for now.